Smasho here, coming at you with the Daily Space Weather here from the Smash News Network, least busted name of news. Thanks for tuning in. Congratulations on realizing the channel exists. Welcome to space, spaced out viewers. Thanks for stargazing with us. And we're starting out here looking at the sun in composite, 304 angstroms plus 193. It's a filament fest. We've got coronal holes. Likelihood of coronal mass ejections, is there one headed toward Earth once again? Likelihood of major flares also quite high. The main flare player up here in the northeastern limb. Let's take a quick trip around the horn here, starting with the northwestern limb. We've got some significant sunspots setting up there. That in itself makes them more likely to produce significant solar flares. And perhaps the most important feature on the western limb is right around the equator. We have like a plasma bridging situation going on here. You can see plasma stretching and being shared between parallel sunspots there as they rotate just off the limb. That could be the harbinger for some significant flares. So that's the second most likely place probably to see large flares. Here is the southwestern limb. Huge filaments visible down here. Also a great view of this coronal hole. It is of south pole orientation, since the solar polar field reversal process is taking its good old time. Here's your southeastern limb. There may be a new active region rising there in the southeast. It's pretty small at the moment. Huge prominence there. Some plasma reorientation looking like it's happening down here. We did have a bunch of CMEs, by the way. Coronal mass ejections. We'll cover those later in the video and tell you the likely trajectories. And there is your major flare player. This sunspot up here has produced some M-class flares in the past 24 hours. That is the time frame depicted in this video. So let's briefly look at the SDO intensitygram. There is your sunspot situation. This group here has evolved a little bit. We see some migration of the trailing umbra there, a little bit of evolution there happening. It's actually making it a little bit more active of a sunspot, so don't be surprised to see even an X-class flare from that sunspot group. It's got umbrae larger than the planet Earth. Here is your SDO colorized magnetogram also. Keep in mind that is yesterday plus today so far. And let's take a brief look at planet Earth. And thanks for leaving a comment, Mike. So here's what's going on planet Earth. We're going to do volcanoes and earthquakes. So Shivaluch is exploding, producing a flight level 170. That's a 17,000-foot ash plume over Kamchatka from Shivaluch. Abiko also erupting, flight level 150. That's a 15,000-foot ash cone over Paramushir Island. Sakurajima also erupting. It's an 8,000-foot ash plume over Kyushu, Japan. Tsubanose-jima, 6,000-foot ash plume from Tsubanose-jima over the Ryukyu Islands. Karengatang exploding, producing a 7,000-foot plume of volcanic ash. Semeru on East Java, Indonesia, exploding, flight level 150. 15,000-foot ash plume over East Java. Tokono exploding, flight level 070. It's a 7,000-foot ash plume. Finally headed to North America. Popocatépetl exploding, flight level 200 over central Mexico. Central America's Guatemala featuring Fuego exploding, flight level 150. Sangay exploding in Ecuador, flight level 210. Revenador has calmed down here. Sabancaya producing a 24,000-foot ash plume as it explodes, flight level 240. And Villarica, some Strombolian activity there. No indication of any major ash plume or flight levels there. Let's take a look at seismicity. These are the past 90 days of what's been shaken on planet Earth. So here is your USGS site. We'll go over quakes that are over a 5 magnitude. So there was a 5.0 in the Band AC. And keep in mind, any earthquake can be a foreshock. Earthquakes in those areas can produce tsunamis. So Also a 5.1 in the Benin Islands region there, south of Japan. Also a 5.0. That one is, that's near Indonesia. Iran had a 5.1. That one came in early this morning at 1:11 Universal Time. And Indonesia also had a 5.5. So there you go. There's a perfect example of a foreshock preceding that 5.5. And let's get back to space with our classic views here. So, one of the best views is the ionized helium view here, 304 angstroms. It's great at all kinds of things. It's good at showing filaments. It does show coronal holes when they're very well defined, like this one. It shows active regions. These bright areas there, those are regions very high in ionized helium. And then you've got pretty good view of solar flares there as well. So you can see some M-class flares happening in the imagery. That's a 24-hour video, by the way. Here's our house favorite wavelength, 171 angstroms. And we saw a tiny uptick in the radio flux. So the 10.7 centimeter radio flux is now up to 161 solar flux units. And for you new viewers out there, the radio flux comes from the upper chromosphere and lower corona, right about where my mouse pointer is there. There is your 1-year graph to put the radio flux into context. And we're going to talk about solar cycles here because of some comments by Tamitha Skov. Yes, Tamitha Skov. She does fine weekly, maybe semi-weekly space weather videos. So make sure you check out her channel. What she said is that Solar Cycle 25 is going to be a stronger solar cycle than not just Solar Cycle 24, but then Solar Cycle 23. So Tamitha expecting a stronger cycle than Solar Cycle 23, which is good news for all of you folks out there alarmed at the idea that the sun could be shutting down because certain channels on YouTube keep spouting nonsense about grand solar minima, a thing that has been thoroughly debunked in the past year or two by the solar activity that we've seen. And the current conditions are NOAA is not forecasting any geomagnetic unrest or geomagnetic storms. So that's just NOAA's forecast. We'll have to show you a little bit more info here a little bit later in the video because there may be a little uptick coming on the way soon. Global geomagnetism is calm at the moment. It's a KP2 situation, planetary K-index, a measurement of global geomagnetism, and here is Earth's magnetic moment from space for the past 4 hours. Now, this is part of the reason why I regularly state that Earth is croissant-shaped, because from the perspective of a solar proton blasting through the solar system, Earth's magnetic field is croissant-shaped. And so, from the perspective of a solar proton, Earth is shaped like a croissant. That's the last 4 hours of Earth's calm magnetic moment from space. Here's Earth's calm magnetic moment from the ground level. That is geospace delta B, meaning changes to Earth's B field. And this will show you the most likely places to see the aurora, pipeline, railway, and power line induction. Again, things pretty calm here at the moment. Next, looking at real-time solar wind, it's quite unremarkable here for the past 24 hours. Current situation is about 421 kilometers per second for the solar wind speed, solar wind density 4.5 protons per cubic centimeter. Continuing on to our GOES magnetometer, getting a little smoother here as we forecasted yesterday. So that is the end of the barely detectable coronal mass ejection impact, which featured a highly positive BZ which didn't create a lot of current at all. It was a nothing burger, as forecasted. Next, looking at the top view ecliptic plane field plot because we want to see the polarity of the heliospheric current sheet, and also this information right here. If you're not familiar with it, immersion in the data might help you with that. It's what we've been doing for the past pushing 6 years. And interestingly enough, this top view ecliptic plane field plot provides massive predictive value. If you know how to read this, if you sort of understand the implications of the solar plasma, the polarization of light, and so on, this data is derived from 51 ground-based magnetometers on stereo A and on stereo B. So at the moment here, no major changes expected. Here's our line of sight field plot. We are solidly in a south pole current sheet. So welcome to the south solar magnetic pole. You are in it in some ways, and it's very, very weak to the point where it's not even detectable on planet Earth. It has to be detected way out at Lagrange point 1, well outside of Earth's magnetosphere. That's about 1 million miles between Earth and Sun. That's where the solar wind is measured, where the SOHO-LASCO C2 and C3 are located, and so forth. Next, we'll look at coronal holes, as the field process is taking a long time here. So we still do see significant North Pole magnetism at the north heliographic pole and significant South Pole magnetism at the south heliographic pole, an indication that we are still not at solar max. You can expect to see most of the magnetism around the equator around solar max, and very limited amounts of magnetism at the pole, because those fields need to still flip. The red will be at the north and the green will be at the south. That's what will happen when we approach our next solar minimum. Anyway, let's take a look at the last image here to look at polarity of coronal holes. We've got all South Pole-oriented coronal holes on the east and North Pole coronal holes on the west. So this is north. This one up here is north. And these are all south. So the sector boundary crossing is somewhere like this. And Earth is solidly in the south solar magnetic pole. It's a normal feature of solar cycle progression. It's nothing to get freaked out about. I'm sure there's plenty of stuff to get freaked out about that's not scary in any way that you can go view on YouTube. And let's move to sunspots. So here's a sunspot situation. No major changes here. A little bit of evolution of sunspot 3234 as we showed earlier in the video. We'll show some great close-ups of that here. A bunch of groups setting, so we expect a dip in the sunspot number unless we see some new regions rise or form. So at the moment, expecting a rather significant dip in both the sunspot number and the radio flux, assuming no growth or new sunspots show up. So here's the last 24 hours. This is 171 angstroms plus SDO continuum. Let's get a little closer. And let's show just the continuum by itself to show all the detail. So this is still a major sunspot group. This group up here is still a major magnetically complex sunspot group. This group here has actually gained a little magnetic complexity, and so has this group. So the likelihood of major solar flares remains quite high. I mean, I don't know what the flare monitor says. There you go. Pretty high probability. Pushing a 42% chance of X-class flares from that, so that is a significant likelihood of additional flares. The likelihood of coronal mass ejection is incredibly high, also nearly 100%. We'll get to that here in a moment. We're going to also do energetic particles and so on. Let's first do the most energetic particles detected on Earth, cosmic rays. So cosmic rays are high energy protons blasting through space at a significant percentage of the speed of light. They are primarily hydrogen nuclei, similar to the solar wind, but coming from extrastellar sources. So sometimes from different galaxies, different star systems, etc. Most cosmic ray point sources are not resolved. In other words, we don't know where most of them come from. There are very few cosmic ray point sources that we are aware of, like the star Deneb in the constellation Cygnus, probably the most important star in the Milky Way galaxy from the perspective of Earth. But in any case, these are the cosmic rays on our several vetted monitors. So this is DOMB Antarctica's cosmic ray monitor. And you can see a major downtick here over the past 30 days at DOMB Antarctica. DOMC Antarctica showing a similar graph there, major downtick over the past 30 days. Going back up north to Oulu, Finland, major downtick at Oulu, Finland as well. So for all of you hoping that that cosmic rays are going to destroy civilization, well, they're ramping down as we expect, as we see a strong solar cycle ramping up. Let's look at some more cosmic ray monitors. The vetted monitors that we typically view on the channel at least once a week. So let's go to Mexico City next. There's your Mexico City Cosmic Ray Observatory, another major downtick over the past 30 days at Mexico City. Let's go back up north to Athens, Greece. Major downtick at Athens, Greece as well. So if you're noticing a pattern developing, an active sun and less cosmic rays, not cosmic rays going off the scale into out of control cosmic ray flux, there you go. Them be the facts. Them be the facts, folks. Major decrease in cosmic ray flux at Athens as well. And let's go way up north to Apatity and Barentsburg, where we also see significant downticks. So major downticks in cosmic ray flux. If you're scared of cosmic rays, I guess we've just made you less frightened because they've been going down precipitously for the past 30 days at all of our vetted monitors. Now, speaking of vetted, if you enjoy the content, please support the channel, perhaps by becoming a member of the Smash Team. We are in the process of writing a paper that explains the mechanism underlying the solar cycles, and that's a process that it was unintentional, really. It includes both inductive and deductive reasoning because, well, there are only so many things happening in space. So we think we've actually figured it out. And by the way, if the paper passes peer review, I should say when it passes peer review, it'll be the most important science paper in hundreds of years. And it will force a rewriting of certain aspects of science. So if you'd like to support that, consider becoming a member of the Smash Team, especially at the silver or gold level. If you want to know the mechanism that we believe underlies the solar sunspot cycles, join at the gold level. We've already informed our gold level subscribers because we need assistance writing the paper because we are highly underfunded. If you've noticed, we don't even have 3,000 subscribers on YouTube. So support the channel that way, as we're paid just this side of nothing to put up the content. And we're still putting out these videos for people like you who are interested in facts about space weather. So if you do log into the Smash Team site, there is a bronze level there as well. That's going to cost you nothing. Just click on posts. You can also find links to the Smash Show merch and so on. You can find links to the Hemp Lucid shop. So check out the mushroom gummies. There's a free offer for free samples on the Twitter page. It's pinned to our Twitter profile, so perhaps go visit Twitter. More on that a little bit later in the video. Shop, buy, solution, etc. Today's featured product is, because we've got merch to help fund the operation as well, Smasher Price, my first pandemic. So congratulations on surviving your first pandemic so far. We appreciate the fine job that you've been doing in not being dead. You've probably made a bunch of terribly difficult decisions that bureaucrats tried to make for you. Hopefully that's working out well, and congratulations on surviving a global scamdemic so far. We do appreciate your not being dead. So if you'd like a souvenir or to send one to your friends and or foes, depicting the pathetic, ridiculous, ineffective, and infantile response of attempting to mask the planet to prevent a respiratory virus transmission. How's that been working? Let us know in the comments what you think about how masking the planet has been working. Has that been effective ever in the history of mankind. If you click the link below the video, you'll find the Redbubble shop in order of best selling. So there's a brief rundown. Some of them are serious, some of them are in jest, and some of them reflect the apolitical views of the Smash News Network, least busted name in news. So let's look at relativistic particles here, as measured by the GO16, and it's flatlined. No spikes in the relativistic particles, despite many significant flares. We haven't seen a significant relativistic particle spike in over a month here. So let's continue on to look at energetic photons. Now, that brings me to another point. There are a lot of really hacky science channels out there that attempt to cover space weather, and it's just embarrassing for them. I mean, I almost feel sorry for some of these people that are so clueless about space weather. Let me explain a simple way to make people understand the difference between a solar flare and a coronal mass ejection, okay? Turn on a fan, stand in front of the fan. You'll feel wind blowing on your face, okay? That's like a coronal mass ejection. That wind consists primarily of protons. In terms of the mass coming out of the fan, that is protons. Now, turn the fan off and turn on a flashlight and shine that on your face. That's like a solar flare. It's just lower frequency light. A solar flare is X-rays, which is photons. Photons are are solar flares. Solar flares are photons. Coronal mass ejections are protons, okay? The one is massive gas blasting through the solar system, and the other one is light. So please don't get them confused. It's quite pathetic watching certain quote science and quote channels get coronal mass ejections and solar flares confused. These are photons of the X-ray variety. And we saw, wow, 3 M-class flares in the past 24 hours. So let's take a look at those. Here's the past 24 hours in SDO 94 plus 131 angstroms. And that could be considered a money shot, but don't worry. We're going to zoom in closer after we show you this plasma bridge. So keep in mind, this plasma does extend beyond the field of view here, most likely. I mean, there's only so much contrast and resolution available in that field of view. So there is a huge plasma bridge there, stretching between transequatorial sunspots. And this group up here, put it this way, this is the second most likely place to see major solar flares, right up here. So keep an eye on that. And when I say ion, pardon the pun. And there's a bit of a money shot. That's the past 24 hours, by the way. And what's that? You'd like an even closer view. Okay, I guess we can accommodate you. So there's our fully zoomed in view there of a series of M-class flares from that sunspot. It remains quite active. In fact, it may be even becoming more active as time goes on. And let's move on to a star chart. So the sun is just peeking over the horizon here over Lehigh Valley, Pennsylvania, chasing Mercury and Saturn. So if you're up before dawn, you might see those two planets rising ahead of the sun in Capricorn. That's what's going on over Lehigh Valley. The location of the Smash News Network, least busted name in news. Next, we'll do a solar system forecast. Keep in mind, this is not to scale, and we'll advance this 1 week. Here's where things will be in a week on this lonely side of the solar system, devoid of gas giants, really devoid of planets in general. That's where we'll be on March 1st. Next, looking at some coronagraphs here, and I believe there is a minor earthly directed coronal mass ejection. So it may not be obvious in this imagery. It does require some additional imagery from stereo A. But it's this CME that you see in the southeast. So it's this one right here. I believe that does have a small Earth-directed component. That's yesterday's imagery. This is today's imagery so far, 29 additional frames there. That's CME coming out of the southeast. That does not appear to have an Earth-directed component. Let's take a look at some more views here from Stereo A and the Soho Lasco C3. So we pause this here at 10:38. And we do see there's actually two separate events happening here, and we covered this yesterday, but there was some missing data. So this is sort of the continuation of that. You've got two different CMEs. So you've got one here, and then you've got one here, and they're separate events. So don't get them confused. But this one, this second one here, this one down here, that one may have a minor Earth-directed component there. No, wait. Actually, the first one looks like it has a minor Earth-directed component. So this one that has this little void in it here, that one looks like it could be earthly directed, or at least part of it, a small part of it. So if we bring this back, maybe not. I changed my mind. I don't think there are any Earth-directed components there in any of those CMEs. So keep in mind, folks, we do the analysis as we stream the content, because what I'm doing here is I'm giving you a live view into what I look at. So, I noticed that space weather was lacking on YouTube. There's a lot of ridiculous coverage of it that makes no sense. I figured there'd be a bunch of channels that want to cover space weather on the daily, but there's just nobody out there citing facts, at least without sprinkling a whole lot of nonsense in with the facts. So here are our 24-hour videos. There's SDO 304 plus Soho Lasco C2 and C3. And a lot of times, folks, it's very deceptive because if you have a CME on the opposite side of the sun, at the same time as you have one on the Earth side of the sun, it looks like a halo when it's actually not. And these are all just separate events. I don't think any of them are earthly directed. And if there is a tiny Earth-directed component in any of those CMEs out of the south and west, out of the west in general, the north and south western limbs, there'll be very minor components, barely detectable. So here's a little zoom in. We'll zoom in a little bit closer here. For example, this one up here, you can actually see the plasma leaving the 304 angstroms wavelength. This one down here is kind of on the far side. And yeah, these are coming out of the far side also. So those are not likely to be earthly directed. And let's continue on here. We don't want the video to be too lengthy. It's time to look at filaments. And check out this filament up here. That one is huge. Also, this one down here looks like it's getting unstable. This one over here is huge. This one here is ejecting on the video. So we've got less filaments than we covered yesterday, but there are still dozens of filaments there on the earthly facing portion of the solar disk. Don't be surprised to see a lot of coronal mass ejections in the coming days. We'll cover it. And we'll also invite you to join us on Twitter to name that filament. So name that filament for the sake of space weather. And join us on Twitter if you haven't. We are utterly shadow banned over there, and we're considering having attorneys send letters to Twitter and to Google and to Meta to unshadow ban us so that we don't have to subpoena your information and take you to court over it. Anyway, that's what's going on with filaments. It's 100% clear that we are shadow banned on social media sites. So join us over there manually as you will not be recommended to our channel or our social media in any way. We are the epitome, the epitome of being shadow banned. We've only been producing the most detailed and comprehensive space weather content for the past pushing 6 years. You can also find a link to the free mushroom gummies giveaway. Keep in mind there is shipping. The free shipping was for the first 5,000 orders, and they quickly went over the 5,000 mark. So we're getting to bonus features here. First, we're going to show some additional imagery of the closest star, starting with this great SDO composite. So give that a minute to load. It's well worth it. And thanks for all the comments, Mike. Come on, SDO website. You can do it. There we go. So that is yesterday plus today in 3 different wavelengths. 2 wavelengths of ionized iron, that's 211 and 171 angstroms, and the 304 angstroms wavelength ionized helium. We do have a trans-equatorial coronal hole rotating in here. So keep an eye on the northeast and the northwestern limb. Those are the most likely places to see major flares. Here's the past couple of hours from the GOES 16 SUVI. And there's some plasma moving around up here, actually. So there's some possible CME action happening. Also a little bit of flaring happening from this sunspot. Let's get the bonus features to see what's going on in the satellite world. So an important feature of space weather is satellite charging hazards. And at the moment, we've got some minor surface charging hazards there in the Central Pacific. No big deal, unlikely to cause any damage or significant signal failures. There are the GOES electron flux measurements by the GOES 16 and GOES 18, the GOES 16 in blue, the GOES 18 in red. Kind of low levels of electron flux here. There is the forecast model by NOAA. The green boxes are the forecast. The yellow diamonds are the observation. There's the 1-year graph to put that in context, just in nominal levels here, not super low. And we'll take a look at the layer of the ionosphere where that's measured. The F layer. That's at about 300 kilometers of altitude. And here's the vibrational frequency of that. Here's your anomalogram of the F layer. You can see really obviously where the South Atlantic anomaly is located, right over the South American continent. And let us know in the comments if you think Earth's magnetic fields are going to reverse, snap back into their normal position, or continue on with a geomagnetic excursion lasting thousands of years. Let us know what you think about the geomagnetic excursion. Statistically speaking, my idea is that the most likely thing is for the magnetic poles to snap back toward the geographic ones. There's the latest image, 1215 universal time ionogram and 1215 universal time anomalygram. That's anomaly in megahertz from a 30-day median. We'll also show the total electron content, which we're proud to say is back today. It depicts the free electrons between your GPS satellite and your handset, a run of about 12,500 miles. Yeah, your GPS satellite. It's at about 12,500 miles of altitude. It's in the inner portion of the outer Van Allen belt. And it's got to transmit a signal through that portion of the Van Allen belt, the outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and the ionosphere. And this depicts the free electrons in that area. The coupled thermosphere, ionosphere, plasmasphere electrodynamics model. Still a little bit anomalous here. We do see this typically a little bit more concentrated around the equator at noon, but we've got low levels of electron flux, so it's fairly average for the electron flux measured by the GOES 16 and GOES 18. No surprises here for our regular viewers, most likely. Those are the most likely places to see GPS errors, and let's bring up the latest imagery of the closest star, El Sol, Helios. We may have another sunspot forming, so check it out on the magnetogram here. We've got this little active region showing up there. Also, perhaps a new sunspot rising down there. So no new umbre yet. Once again, the places to keep an eye on throughout the day today would be the northwest and the northeastern limb, because of this sunspot especially. That is quite active, and there is a bunch of filamentary activity up here looking like it could release at any moment. So here's your rock back. There's the magnetogram and intensitygram. And before we get to our meteorology segment of the video, take a moment to visit our websites. If you haven't checked out the website links, you can find links below the video to all kinds of different locations. Smashomash.com is the official website of the Smash team. That is our homepage, so visit the links there if you're unable or unwilling to open your cobweb-encrusted wallet and help us out by actually donating to our process. Visit our links and help us out with clicks. And welcome to the Neo Renaissance. Congratulations on realizing that the channel exists. Press like, press subscribe, press share. Don't forget to visit our playlists. You'll find videos that aren't about space weather on our playlists. Although most of our content is. We're pushing 6 years of daily space weather videos, and it's time to check out meteorology. So we're looking at the lowest pressure in the world here, 952 hectopascals. Multiple low pressure zones there in the Southern Ocean, and huge pressure gradients there on Antarctica as well. You can see very high pressure around the center of the continent, and then very low pressure in the oceans. That's high pressure. That's low pressure. And that is the lowest pressure in the world. That's basically hurricane force pressures there, 952 hectopascals. The Southern Ocean is not what you'd call a hospitable place. Of course, low pressure dominating most of the U.S. right now. There's a lot of precipitation. And we'll get to that here in a moment. First, the winds. So there is where she blows on the surface of the eastern world. There are the jet streams, the best global weather pattern signal. If you want to forecast global weather patterns, the jet stream is a good place to start. There are the 250 hectopascal winds over the Americas. Strong jet stream doubled up there over the western U.S. and converging around Lake Michigan. These are the surface winds of the western world. Strong winds there in the southwestern U.S., as well as a strong onshore wind around the Gulf states. Like sands through the hourglass of time, these are the surface winds of the central world, like Europe, Africa, and the Middle East, and these are the jet streams. So there is that. This is clouds and fog over the Americas as we zoom in closer and closer to the U.S., and we allow NASA to depict croissant Earth on this spherical template. Yeah, Earth, it's croissant-shaped. Don't believe all the lies from NASA. NASA was founded by real Nazis, folks. And that's why they're trying to convince you the world is spherical. I'm just kidding, folks. Flat Earth is some low-hanging fruit. Let's check out our weather.gov map. We're going to scroll down to show you the key. There is the key. Don't drive through floodwaters, please. We've got some major winter storm warnings across a huge portion of the U.S., including blizzard warnings. And let's get to some forecasts. So first, our temperature anomaly forecast. This is temperature anomaly in degrees Celsius based on the GFS 72-hour forecast. Warm temperatures sticking around the northeast for a couple of days here, and very, very cold temperatures intruding into especially the north-central portion of the U.S., but most of the west seeing anomalously cold temperatures. Here's pressure and precipitation for the next 72 hours based on the same model, the GFS. Some heavy snow there coming to large portions of the western part of the country. Also, north central U.S. And last but not least, this is a accumulated positive snow depth change in inches for the next 72 hours, again, based on the GFS model. So, an additional foot of snow expected there for South Dakota, Minnesota, and large portions of the Rockies. No matter how much hot air comes out of Colorado, it just keeps snowing. Again, that's your 72-hour GFS total accumulated positive snow depth change forecast in inches. Shout out to Smash Staff's mom. They're forecasting another 3+ feet right around your location. Dag, California getting plastered with some heavy snow. So there's the Euro model for the snow over the next 3 days. And there's the GFS model. You can see GFS model predicting quite a bit more snow for California. And there's the Euro model once again. GFS, Euro for the next 3 days of new snow. Pretty similar, though, the way those are lined up. Oh, one other thing to notice. There's going to be major ice storms, which are starting right now in northwestern Ohio. So major ice storm here. It's going to spread from Iowa all the way to New Jersey. So, yeah, huge ice storm here coming when warm water falls on cold ground. It can make for some bad driving conditions indeed. Anyway, I don't know why it does that. Windy.com. It's got a great mobile app, by the way, so check that out if you haven't. Got some lightning over the U.S. over the past 10 hours. In Texas, Arizona, also Illinois, Indiana, and other states. Let's see if we have any current strikes going on. And it looks like we indeed do. So let's check it out here. Indiana's got some active lightning, it looks like. While we wait for that to refresh, next time you hear thunder, check out lightningmaps.org. We are not paid to say this. We have no actual affiliation. All right. And thanks for leaving a comment. IRBG. You're welcome for the content. It is our pleasure. We realized there was a niche in space weather, so we filled it instead of complaining about the pathetic attempts by various other YouTube channels to create coherent content about space weather. Shout out to Tamitha Scove for creating coherent content about space weather. All right, let's close this thing out. We've got the U.S. Doppler radar map. There is the full 50 states of AUSA, the allegedly United States of America. Former nation, now Banana Republic. Here is the U.S. Doppler radar map. A lot of precipitation there. Much of it in the form of snow. We'll show shortwave radiation. That's infrared, by the way. It'll show clouds and fog when it's too dark to use the visible satellite. And there is your water vapor map. There is a compression happening here in Texas and Oklahoma, as we've got high pressure, evidenced by this dry mass of air right here. This is effectively high pressure. This is effectively low pressure. And this is effectively high pressure. Also another compression zone happening there. We've got some sandwiching there of moisture, and that creates a massive pressure gradient. And the water is no longer able to be sustained as vapor, and it ends up showing up as precipitation. Hopefully that helps. There's your U.S. Doppler radar one more time as we close this video out with our recap. Clouds and fog over AUSA. And there is water vapor. And thanks for tuning into the Smash News Network, least busted name in news. Once again, congratulations on realizing the channel exists. Frankly, we are surprised that you found that the channel exists. In the meantime, I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.